So in the last model, when we were doing calculations, we explored very briefly a library called NumPy. Now NumPy, if you've actually started exploring any data science courses already, you may have actually already encountered NumPy. You'll see a lot of modules talking about using the NumPy objects and things like that, because NumPy is actually a library that's used not just for calculations in general, but it's also designed for doing like matrix calculations. So because it can do matrix calculations, it needs a way of storing matrices, so it has an ability to store things like arrays and such as well. Now, why am I saying all this? Well, because it turns out if we take a closer look at the values that we predicted when we trained, or when we tested specifically our model, you might notice something interesting. So when we called predict for our model and passed in the test data and asked it to create some predictive values, if you actually look at the type of Y prediction, you might have noticed something, which is that Y prediction, if you look at the data type, is actually a NumPy array. So it's not actually a data frame, whereas Y test is a data frame. Now, this is significant because so far, we've been working with pandas data frames. So when we were doing queries, we learned how to query a pandas data frame. When we were looking at information, like how do I display the first few rows or the last 10 rows and so on, we were doing all these with methods on pandas data frames. So it's even possible, maybe when you were trying some of this out yourself, that you did something like, hey, let's do a ypred.tail to look at the last 5 rows, and it failed because that method doesn't exist on NumPy arrays. That's a method that only exists on a data frame. So the other thing that might happen is you might be doing things like trying to merge 2 data frames together or split 2 data frames apart, and you try and do, again, those actions on this ypred, and it'll all fail because, again, it's not a data frame. It's a NumPy array. So let's just talk a little bit more about NumPy and explore that some more. So it's a Python package for scientific computing used for a lot of matrix calculations. It has an assortment of classes and methods that'll help you out. And when you're doing Python for data science, you'll end up working with a mix of pandas objects and methods as well as NumPy objects and methods. In NumPy, you have an array. So in pandas, we had a series. That's very similar to a one-dimensional NumPy array. In fact, if I want to declare it, if you compare the code for a NumPy array on the left and a pandas series on the other side, you'll see the code is almost identical. Here I can tell it's an array because I declared it as a NumPy array. Here I declared it as a pandas series, but the syntax is the same. And if I want to print all the values in the series or a specific value in the series, the syntax is again still the same. The big difference is you have an implicit index with NumPy arrays, and you have an explicit index that's displayed 0, 1, 2 when you have a pandas series. And they have different functionality. A 2-dimensional NumPy array is very similar to a pandas data frame in terms of its structure. And when you're writing the code to access it and to create it, again, it's going to look very similar. I declare a NumPy array, and I specify the values for each row and each column. And if I want to print all the values, I just pass in the array name. If I want a particular row or a particular value, I specify the index column position and the index row position. Row, then column, just in that order. And then if I'm using a data frame, again, pass in the values for the different columns and the different rows, print the entire data frame, or you can use that iloc, index location, to specify a row and column position to request a specific value. So again, at first glance, they seem to be almost identical. But they are different classes and they have different capabilities. So one of the things you're going to run into is there's going to be times where you may want the functionality of a data frame, but it's in a NumPy array, or maybe you want the functionality of a NumPy array and it's in a data frame. Or you're trying to merge data from 2 objects together. One's NumPy, one's pandas data, one's a NumPy array, one's a data frame. And when you try to merge them, you'll get errors saying they're different data types. So you might need to move data between a NumPy and a pandas object. I'll give you one example here. In this case, if I wanted my predicted values to be in a pandas data frame instead of a NumPy array, all I have to do is call the DataFrame constructor, pass in the NumPy array, that's an object it will accept, and it will return to me a data frame containing the same values. Now you can see that ypred is still a NumPy array, but my ypred data frame is actually a data frame. So as you explore that world of data science, be prepared. This is going to happen to you. You will have times when something's in a NumPy object and you need it in a pandas object, or something's in a pandas object and you need it in a NumPy object. I'm not going to cover every possible conversion that might exist, but be prepared for it, and there's lots of great documentation out to help you when you're looking at a specific scenario. Now let's take a look at this in the actual code.